Here is a warm-up question for you. You have to find the partial fraction decomposition of x plus 13 divided by x squared minus x minus 20. You can feel free to use your book to help you, or you can also look at the previous video which was on partial fraction decomposition of rational expressions with linear denominators. When you have attempted the question and you are ready to view the solution, you can play this clip again. Welcome back. Our warm-up question was to find the partial fraction decomposition of x plus 13 divided by x squared minus x minus 20. The first thing we can do is we can rewrite the expression as partial fractions with constant numerators a and b and denominators that are linear factors of the original denominator. So you can see on the right hand side a and b are constant numerators and we have linear factors of the original denominator. The next step would be to multiply each side by the lowest common denominator, which is x squared minus x minus 20. On the left hand side, that would leave you with the numerator alone, which is x plus 13. On the right hand side, we would have a lots of x plus 4 because x minus 5 will be cancelled. And then for the next fraction, we have b over x plus 4. X plus 4 will be cancelled, leaving you with b lots of x minus 5. The next step would be to expand those brackets. We have ax plus 4a plus bx minus 5b. We can group the like terms and we will get 1x plus 13, which is what we have on the left hand side. We had ax and plus bx, so we can combine it together, group them and say we have a plus b lots of x. We had 4a minus 5b, so we can group them together and say it's 4a minus 5b. The next step is that we can equate the coefficients on the left and right hand side of the equation to obtain a system of two equations and solve for a and b. So we would have a plus b would equal to 1 and 4a minus 5b would equal to 13. If we solve the system of equations, we will obtain a is equal to 2 and b is equal to negative 1. So that would leave us with a over x minus 5 plus b over x plus 4. We will substitute those values into a and b, and the solution is 2 over x minus 5 plus negative 1 over x plus 4. Partial fraction. Prime quadratic factors. Prime quadratic factors. If the denominators of a rational expression contains a prime quadratic factor, the partial fraction decomposition must include a partial fraction with a linear numerator of the form bx plus c for each power of this factor. Denominator with prime quadratic factors. We have to find the partial fraction decomposition of x to the power of 4 minus 2x cubed plus 8x squared minus 5x plus 16 over x lots of x squared plus 4 squared. This expression is proper. The denominator has one linear factor and one prime quadratic factor of multiplicity 2. We can express it as a over x plus bx plus c over x squared plus 4 plus dx plus e over x squared plus 4 all squared. The next thing that we can do is multiply both sides by the denominator of this fraction. When we do so, we are only left with the numerator of this fraction, which is x to the power of 4 minus 2x cubed plus 8x squared minus 5x plus 16, which equals to, on the right hand side, we have a lots of x squared plus 4 squared plus bx plus c times x squared plus 4 plus dx plus e lots of x. The next thing that we can do is multiply out these brackets on the right hand side, and that would leave us with a x to the power of 4 plus 8a x squared plus 16a plus b x to the power of 4 plus cx cubed plus 4b x squared plus 4c x plus dx squared plus ex. The next thing that we can start to do is we can start to group some of these terms together. We have ax to the power of 4 and we have bx to the power of 4. We can group them together as a plus b lots of x to the power of 4. When we look at x cubed, we have cx cubed. We'll write that next. Now it's time to look at x squared. We have 8a x squared plus 4b x squared plus dx squared. So we can group them together as 8a plus 4b plus d lots of x squared. It's time to look at the x's. We have 4cx plus ex, which can be grouped together as 4c plus e lots of x. Finally, we have 16a, and we will write plus 16a at the end. At the bottom of the screen, we got as far as 1x to the power of 4 minus 2x cubed plus 8x squared minus 5x plus 16 equals a plus b lots of x to the power of 4 plus cx cubed plus 8a plus 4b plus d lots of x squared plus 4c plus e lots of x plus 16a. We can write and solve the system of equations obtained by equating coefficients. So we can say a plus b equals to 1. We can see a plus b and 1. C equals to negative 2. So we have C equals to negative 2. We have 8a plus 4b plus d, which equals to 8. You can see here. 4c plus e equals to negative 5. And finally, 16a equals 16. Let's try to solve these equations to work out the values. We are already given c is negative 2. I can substitute c equals negative 2 into this expression and work out the value of e. That would give me 3, because 4 lots of negative 2 is negative 8, plus 3 will equal negative 5. I can also work out the value of a, because 16a equals 16, so a is equal to 1, because 16 times 1 gives me 16. I can substitute the value of a equals 1 into the top equation. So b would equal to 0, because 1 plus 0 would equal to 1. Finally, I can work out the value of d by substituting a equals 1 and b equals 0 into the equation, and that would give us d equals 0. So finally, we can say that the final solution is 1 over x minus 2 over x squared plus 4 plus 3 over x squared plus 4 squared. Here is a question for you to try. you have to find the partial fraction decomposition of 4x cubed minus 7x over x squared plus x plus 1 all squared. Please try to attempt this question. If you need more help, you can watch the previous example that we have covered together. When you have attempted this question and you have answered and would like to view the solution, you can play this clip again. Welcome back. You had to find the partial fraction decomposition of 4x cubed minus 7x over x squared plus x plus 1 all squared. This expression is proper. The denominator has one prime quadratic factor of multiplicity 2. We can say that this is the same as ax plus b over x squared plus x plus 1 plus cx plus d over x squared plus x plus 1 all squared. We will multiply both sides with the denominator of this fraction, and that would leave us with 4x cubed minus 7x equals ax plus b lots of x squared plus x plus 1 plus cx plus d. The next step would be to multiply out these brackets, and that would give us ax cubed plus ax squared plus bx squared plus ax plus bx plus cx plus b plus d. Now we can try to group these. We can say this is the same as ax cubed. We have ax squared plus bx squared, so we can group them as a plus b lots of x squared. We have ax plus bx plus cx, which can be grouped as a plus b plus c lots of x plus b plus d. So this is what we had at the bottom of the screen. Now we will write and solve the system of equations obtained by equating coefficients. We can see that ax cubed on the right hand side, and we have 4x cubed on the left hand side, so we can say a equals 4. We have a plus b as a coefficient for x squared, but we do not have an x squared term here on the left hand side, so we can say a plus b equals 0. Time to look at the coefficients for the term x. We have a plus b plus c lots of x, and we have negative 7x, so a plus b plus c equals negative 7. Finally, b plus d is the constant on this side, but we do not have one on the left hand side, so we can say b plus d equals 0. So firstly, we already know a is equal to 4. I can substitute a equals 4 into the second equation, and that would give me b equals to negative 4. I can substitute a and b into the third equation, and that would give me c equals negative 7. Finally, to work out the value of d, you can substitute b equals negative 4 into the equation, and that would give us d equals 4. Finally, we can express this fraction as 4x minus 4 over x squared plus x plus 1 plus negative 7x plus 4 over x squared plus x plus 1 all squared.